As in the figure, a hole is to be punched out of a plate having a shearing strength of 40 kSI. The compressive stress in the punch is limited to 50 kSI. A. Compute the maximum thickness of plate from which a hole 2.5 inch in diameter can be punched. B. If the plate is 0.25 inch thick, determine the diameter of the smallest hole that can be punched. So for letter A, compute the maximum thickness of the plate. That means the axial force that is going to be resisted by the punch will also be at its maximum. That means we are going to use the allowable stress of 50 kSI for our compressive stress. And from there, we are going to solve for the axial load that is going to be resisted by the punch. Okay, so from this drawing, okay, so for letter A, we need to cut a section here. So the free body diagram will be like this. There's the load here, P, and this will be the axial force, the internal axial force. So this punch will be, or is going to punch a hole with a diameter of 2.5 inch. If we sum up forces vertical equals 0, can see that our normal force is equal to P. And then from the compressive stress formula, stress equals N over the area, where N equals P. So, and the allowable compressive stress is 50 kSI. So this is P, and the area would be this one. That's pi times the diameter 2.5 square over 4. So this will give you a P, the external force P equals 50 times pi times 2.5 square divided by 4 equals 245.44 pounds. Okay, so with the maximum external force P already known, let us determine the thickness of the plate. So say this is the plate. So that's the plate. We do not know its thickness. And then there is a hole that is going to be punched out of this plate. Let's say the hole is like this. Okay. The diameter, of course, is 2.5 inch. And then there's a load P equal to 245.44 pounds. And it is going to be resisted by the shear stresses here. Okay, so that will be your shear stress, which the resultant is actually the shear force. So from the shear stress formula, that's V over A. So our area here is this one, this area here. Okay, so this area here. So that is just the circumference multiplied by the thickness. So the area is the circumference times the thickness T. Our shearing stress is given to be 40 KSI. And then from summation of forces vertical, we can see that our B is equal to 245.44 pounds. So substitute this here, we get shearing stress equals B over the area. And we'll get a thickness of 0.781 inch. That will be the maximum thickness if we are going to punch a hole about 2.5 inch in diameter. Letter B, if the plate thickness is given now, it's 0.25 inch. Determine the diameter of the smallest hole that can be punched out of this plate. So this time, the diameter is unknown. So this one is unknown. So let's go back to the compressive stress. So for the compressive stress, this is the area, but the diameter here is unknown. Okay? So again, we have our external load P resisted by the internal load N. Again, N is equal to P. Okay? So N equals P, and then our stress, which is N over area, now becomes stress here is 50 psi. N is now P divided by the area, which is pi d square over 4. So we will have P in terms of D. That will be 50 times pi d square over 4. Let's just say P equals to that. Now, in shearing stress, so this is for the plate with thickness equals 0.25. Now, shearing stress is shear force over area. Shear force is equal to P, which is this one. Okay? The area is the perimeter pi d, where d is unknown, times the thickness of 0.25. The shearing stress given, that's 40, and our B equals P, and P equals this. Divided by the area, pi d times 0.25. So this will cancel out, as d over here cancels out. So we only have 1d here. So our d is now 40 times 0.25 times 4 divided by 50. D equals 0.8 inch.